Hey, Precog, welcome. Here's your do now for today. Pretend that there are these two wheels of fish. We'll call it wheel of fish A and wheel of fish B, as in the tiny picture there. And pretend like on a previous day, you already calculated the mean absolute deviation, variance, and standard deviation for each of those two spinners. And the answers are listed there on the table. And then here's the do now. Pretend that just for fun, you want to add together all of the similar summary stats, mean plus the mean, mad plus the mad, variance plus variance, and so on. All right, go ahead and add those together. Hit pause on the video till you got your answers. Well, welcome back. I hope that you got the same thing that I did when I added these together. Let's also pretend, as long as we're playing pretend, that you separately combined all the possible different ways you could spin spinner A and spinner B, this spin and that spin, and add those numbers together, and you made a big table, and you recalculated over there the mean absolute deviation, variance, and standard deviation for the combined sample space of spinning spinners A and B. And we have those correct answers down here. Let's compare the answers you just got by adding the answers for A and B in red and green to the correct answer, which is in purple, and see if they worked correctly or not. So I got 5.75 when I added the means, and when I recalculated, I also got 5.75. So yes, I could just add those two red and green means together. What about the mean absolute deviation? 1.25 when I just added, and 0.9 when I recalculated. So those are not the same. For the variance, 1.19 both times. I could recalculate with the bigger sample space or just add the variance. And with the standard deviation, just adding those two standard deviations together, I got 1.53, but the correct answer is 1.09. And so that does not give us the same answer. Well, that was interesting. Here's what we're going to do today. We're going to look at summary statistics for combined events, in particular focusing on variance and standard deviation. So we'll be able to calculate the variance and the standard deviation for combined events. What do I mean by combined events? Well, basically the same thing I just gave as an example in the do now. You got, like, say, two spinners, two wheels of fish, two dice, whatever. You're going to do this event, whatever that outcome is, you're going to add it together to the result of this other event. So here is a table presenting how we can find summary statistics for combining two events. So you have two totally separate events. We'll call it event A and event B. Both of them have numerical outcomes like wheels of fish. So for combining the two sample spaces, event A plus event B, the size of the sample space is going to increase. So if you had 4 spaces on spinner A and you had 4 spaces on spinner B, we're going to multiply 4 times 4 to get the new sample space. It'll be much larger. To calculate the mean of that combined sample space, we can just take the mean of spinner A and the mean of spinner B and just add those two means together, which is much faster than recalculating the mean for the whole new sample space. Mean absolute deviation did not work when we tried to just add the mean absolute deviation of the two separate events. So we'll have to actually recalculate. If we need that answer, we'll have to create a larger calculation table for that combined sample space. Variance, we were able to add successfully. We took the variance of spinner A and the variance of spinner B, just add them together. And that gives us the correct answer for the variance if we had recalculated with a larger calculation table on that new larger sample space. And the standard deviation was the last one. That did not work to add them together, so we'll have to recalculate. But standard deviation has a really easy way to recalculate. We don't actually need that whole entire table. We just need our answer for the variance, and we do the square root of that, and that gives us the standard deviation. Like, that is how you always do standard deviation, no matter what. As long as you have the variance, you just do the square root, and there's your standard deviation. Okay, so there are 4 summary statistics that we have been talking about the last couple of days. Mean is a measure of center, and there are other measures of center, but mean is the one that we're going to use from here on out. It's got the most applications for all the things we still need to learn. It's the only application for all the things we need to learn. And then for the measures of spread, we've got three of them: mean absolute deviation, variance, standard deviation. All of those are measures of spread. The mean absolute deviation has the one advantage it has is it's easiest to calculate. But if we start looking at any kind of combined events or any of the other stuff we're going to look at, repeated events, all this other stuff we're going to do, mean absolute deviation just does not have an application there. It does not have an easy way to calculate in larger, more complicated circumstances. And so it is virtually never used for any sort of statistics beyond where we are right now. So what do you call that? Like, it's used in elementary or basic statistics, and the more advanced stuff, mean absolute deviation, just is not ever used. So we can kind of ignore it from this point on, except that it is a necessary step in our process of calculating the variance and standard deviation. Standard deviation is the one that is the most important. That is the measure of spread which has the most far-reaching implications, the most far-reaching applications, is the most important one. However, it doesn't have quite as many advantages as far as ease of calculation as what variance does. So we got to keep track of variance, but really only because it's easy to work with, and then we use the variance to get the standard deviation just by doing the square root. All right. So in other words, if you didn't like the table, here's just the word form. When combining two, this does the exact same thing. If you're combining events like spinning two spinners, you can add together the expected value of each of the individual events, or the expected value is same as mean. Just take the mean of one event, the mean of the other, add them together. That'll give you the mean of the combined sample space. And second paragraph, you can add the variance of each independent event, and that will give you the correct variance for the combined sample space. In red, you cannot ever, under any circumstances, add the standard deviations of two events together. It is not correct. You can't do that. So in order to get the standard deviation, we have to take the square root of the variance. Always. That's how you get standard deviation. No matter what we're doing, what kind of complicated situation there is, you always get the standard deviation by taking the square root of the variance. Examples. So here are some results that we have calculated. You've actually calculated these over the last several days. There's a wheel of fish A, a wheel of fish B, a wheel of fish C, a standard six-sided die. Okay, so they're just listed in the table for organizational purposes. Here are the answers that you have gotten previously. We're going to use those to answer the following question. Find the expected value, the variance, and the standard deviation for combining spinners A and spinner C. All right, so let's focus on what we're doing here. So we want spinner A and we want spinner C. So to get the combined mean, or the combined expected value, I can just add. So the expected value of A was 4 and of C was 4, add those together and get 8. The variance, I can just add. So the variance on A was 0.5, the variance on C was 48, add them together. And for standard deviation, the only option I ever have is to take the square root of the variance. So I'm going to have to do the square root of that 48.5, which equals just about 7. Let me calculate 48.5 square root 6.9, depending on how many decimal places we want. Just a hair less than 7. Next example, same idea. So there's that same table of results that we have calculated to previous problems over the last several days. This time, we're going to combine spinner A and rolling a standard six-sided die. All right, well, so to find the expected value or the mean, I can just add. So 4 plus 3.5, that's 7.5. To get the variance, 0.5 and 2.9, I can just add those. So that'll be 3.4. To get the standard deviation, I don't care what the previous standard deviations were. That doesn't make any difference. I need to do the square root of that variance. So the square root of 3.4 is 1.844. Last example, what if we were to combine spinner B and a die? So you get to spin spinner B, whatever number you get, keep that number, roll the die, whatever number you get there, we're going to add them together. So what are all the possible combinations of spinning spinner B and rolling a die, adding them together? All right, well, I need spinner B and I need a die, and we can add the expected values. So 1.75 plus 3.5, that gives me 5.25. Variances, I can add those together. 0.7 and 2.9 gives me 3.6. Standard deviations, I don't even care what the standard deviation was earlier. I have to do the square root of 3.6. And that 1.897